Be careful adding or subtracting decimals. Can't be too careful with the placement. You need to.
Welcome to Nat, M, and Lexi's podcast.
Heck yeah!
Woo! Hey Emily, have you ever wanted to get an Amazon Alexa?
Why, yes, I have.
I think they have them on Amazon. Let's go look.
Great idea.
Oh, they do have one. Let's get it.
Sounds good to me.
Hey Alexa, what's a decimal?
A decimal point is a point or a dot used to separate the whole part of a number from the fraction part of a number. A decimal is basically just a fraction written in simple form. Instead of writing 1/2, for example, you can express the fraction as a decimal, 0.5, where the 0 is in the ones place and the 5 is in the tens place.
Wow. That makes sense. So a fraction, which is also a mixed number, can be turned into a decimal and vice versa. So when you're converting a decimal to a mixed number, the easiest way to accomplish this is with a calculator. But we don't always have calculators, so we have to go to the old-fashioned hand calculations. So for example, if we change 4.5 to a mixed number, the 4 is in the ones place and represents a whole number. The 5 is in the tenths place, which can be changed to 5/10. The 5/10 are in the fraction. However, with this example, the 5/10 can be simplified to 1/2. So your final answer is 4 1/2. Another example is 0.75. The decimal has a number in the tenths and hundredths place. Therefore, the fraction form is 75/100. Once simplified, you get 3/4. So when changing fractions to decimals, you have to change the mixed number to the decimal form. To do this, you need to follow 3 steps. Step 1. If you have a mixed number, you need to change it to an improper fraction. Step 2. Divide the numerator of the mixed number by the denominator. And then step 3. If the division isn't even, just round off the decimal. To change 3/4 to a decimal, you divide 3 by 4. The answer is 0.75. However, what if there is a whole number included? For example, 5 3/4. In this situation, you simply multiply the denominator by the whole number. In this case, the answer is 20. And then add the numerator to the answer, providing the total of 23. Then create the improper fraction of 23/4 and divide 4 into 23. This provides you with the answer of 5.75. There's no question that decimals and mixed numbers can be a bit confusing at first. However, if you take your time and work through the steps, you will be a master at converting decimals to fractions and vice versa in no time. Hey Alexa, can you play a song to help me understand adding and subtracting decimals?
Sure can.
301 thousandths minus 2/10. Line up the tenths, hundreds, and thousands. When right of a number there's an empty space, writing zeros can help by holding the place.
The decimal point drops directly below so that the points line up in a row. Subtract each place value to find the difference. Equals 101 thousandths. Find a sum or difference. It just makes sense. To line up the tens. Hundreds and thousands.
To add 500s and 6,000s, line up the place values with confidence. When right of a number there's an empty space, writing zeros can help by holding the place.
The decimal point drops through.
Wow, Alexa, that song's going to be stuck in my head. What about you, Em?
That song's a bop.
We like to jam to that song. Put it on repeat.
You got it.
Hey Alexa, how do we add and subtract decimals?
Well, before doing anything with decimals, you should become efficient in using the 4 basic operations involving decimals, which are addition, subtraction, multiplication, and division. First off, adding and subtracting decimals is fairly easy. To add or subtract, all you do is line up the decimal points and then add or subtract the same manner you would adding a whole number.
That makes so much sense. I looked up how to multiply decimals because I was confused. So it says if you already know how to multiply, then multiplying decimals will be easy. There's just one extra step you need to take. The first step is you need to multiply the numbers just like normal, as if the decimal point wasn't there. Next, you need to add in the decimal point to the answer. This is the only tricky part. You add up the decimal places there are in the numbers you multiplied. Then you put that many decimal places in the answer. Now that I know how to multiply decimals, it would make sense that I would learn how to divide them. When you're dividing a number with a decimal point by a whole number, dividing decimals is pretty simple. Divide the number as you normally would, using long division. Then bring the decimal point directly up from the dividend. If the divisor is a decimal number rather than a whole number, then you will need to take an extra step. In this step, you convert the divisor from a decimal number to a whole number. You do this by moving the decimal point to the right in the divisor until there are no more numbers other than 0 to the right of the decimal point. Then you move the decimal point to the right the same number of places in the dividend. There are only 2 important things to remember when dividing decimals. The first is that you move the decimal point directly up in your long division. The second is that you always move the decimal points on both to the divisor and the dividend to where the divisor is a whole number. Hey Alexa, have you seen Emily? I can't seem to find her.
No, I have no idea where she went.
Hey, podcasters, E-Money here. Now, I know that there are many misconceptions about decimals, which is why I felt it was necessary to discuss some of those misconceptions in this podcast.
Wait, decimals are like fractions, right? So like 3/4 equals 0.34, right?
Of course. 4.79 is greater than 4.8 because 79 is way more than 8.
Decimals actually get smaller and smaller the farther you go to the right of the decimal point. That's why 0.431 is smaller than 0.4. All right. Well, many teachers encounter these and other decimal misconceptions expressed by students. Lexi's fraction rule, Nat's longer is larger generalization, and my longer is smaller theory are all common reasoning errors. It is easy to see why the confusion emerges. Understanding the decimal system can be challenging, requiring coordination of place value concepts with features of whole number and fraction knowledge. Ultimately, the learner must discern if and how previously learned concepts and procedures apply. The process is complex and misconceptions will naturally arise. In a crazy learning environment, teachers encourage students to guess because errors and incomplete understandings often present powerful learning opportunities. However, when ignored or inadvertently reinforced, misconceptions can delay future learning. That is why it is important to remember that strategic instructional choices help students develop understanding and address potential misconceptions. When these decimal misconceptions go unnoticed in grades 4 and 5th, this presents problems later on. In middle school, when the mathematics content builds upon foundational ideas, and to avoid and address such misconceptions, we provide 2 teaching strategies. The first one is posing purposeful tasks and questions, and the second is varying representations. Misconceptions can be difficult to detect. When teachers are unable to identify or understand a student's misconception, they might develop an incorrect assumption about the student's mathematical knowledge. Misconceptions can be especially tricky when students are inconsistently getting the right answer by using the wrong procedures. For example, solving a multi-digit subtraction problem from left to right will produce a correct answer in cases where no regrouping is required, or when an alternative algorithm is used. Attending to student thinking is essential when detecting the meaning of a misconception. To help students recognize and address misconceptions, teachers can introduce new concepts using, you guessed it, multiple contexts and representations that support students in mathematical conceptual understanding, such as those outlined earlier in this podcast. The use of multiple representations and explaining one's thinking will also make misconceptions highly visible for teachers, and they are able to help guide the student in the right direction. It is critical that teachers examine students' work, both in the moment and written work, and they unpack what they attend to and how they interpret the student work to develop productive and meaningful practices that will further students' mathematical thinking.
Hey Alexa, do you want to hear something funny that I did the other day?
I mean, I would love to hear something funny you did.
So the other day, I was trying to add up how much my groceries would be, but I forgot to line up the decimal point. So my total was like $1,000. I don't have $1,000.
So what happened?
So I had to go back and recheck my math because that answer really didn't make sense. I figured out that it wasn't $1,000. It was only $100. Silly me.
Silly you is right. That reminds me, yesterday when I went to the mall, I got in a full-blown argument with the clerk or the lady that was checking me out because my total was wrong and I completely forgot that I had to multiply the sales tax because North Dakota has sales tax.
That's funny. So did you end up apologizing afterwards?
Yeah, I did. I felt pretty bad because I got in a really bad argument with her, and then it turned out that I was wrong. So
You have to double check your math, Alexa.
I know.
Before things get heated.
All right, guys, that's all for this week.
Stay tuned for next week and we'll talk about fractions.
And enjoy this rap created by us. Word.
Call her decimal.
Now it might seem crazy what I'm about to say. Decimals are easy, so take a break. Tenths, hundredths, thousands, they're not the same. To the right of the decimal, they'll be in place. Because I'm learning. Clap along if you know a decimal is a fraction. Because I'm learning. Woo! Clap along if you know, if you can say it, you can write it. Because I'm learning. Yeah! Clap along if you know a decimal is a fraction. Because I'm learning. Clap along if you know, if you can say it, you can write it. Clap along, clap along.
Woo! And we out.
Sound like the Migos.